everyone, I am Sakshi Kushwaha and welcome back to yet another video on machine learning tutorials. Till now we have learned how to build model and what are the 8 steps for building any model. In the previous video we have learned how to build model and how to check accuracy for classification problem. But in this video we are going to learn how to build model for a regression problem and check accuracy of it. Okay, there are two methods for checking accuracy, one for classification problem and one for regression problem. First open the colab. So you have to open the colab. You have to click in this new notebook. And firstly, I am going to write all the 8 steps. What are the 8 steps? So step 1 is import libraries. Okay, what is the step 2? Step 2 is import the data. Okay, import data. And what is the step 3? And first, once you have a data, then the next thing you can do is define features and target variables. So define X, it means features and target variables. It means Y. Okay. What is the fourth step? Fourth step, once you have a X and Y, then you have the next thing you can do is split your data into training data set and testing data set. So you have to write step 4 is train, test and split. Okay. And what is the step 5? Once you have a training set and training data set and testing data set, then the step 5 is uh, identify the problem type of problem. Okay, identify the type of problem and select the model or algorithm. Okay, select the model. And what is the step 5? Once you have the model, once you selected the model, then the step 6 is train that model, or what the machine learning is done. So train or fit the model, whatever the model you have built. Okay. And what is the step 7? Step 7 is once you have your trained model, then you have to predict your model. So predict the model. And once prediction is done, then the next step you can do is check the accuracy, calculate the accuracy of it. Okay. So calculate the accuracy of the model. Okay, so let's start from step 1. Step 1 is import libraries. So import the library. What are the necessary libraries? So till now only one library is required, like import pandas as pd. Okay, yeah. And the second step is import data. So we are going to done what is the problem name is chance of admission, because we are yeah, we are going to predict the chances of admission. Okay, chances of admission. So where is the data set? So you have to just download from the Kaggle. uh, yeah so here is the your CSV file, admission underscore predict.csv. it is a size of 12.9 KB. It is very small file, so you have to just download it. Okay, and here you see it is downloaded successfully. Okay, here is the file. So come to your collab notebook and just rename this file to the chances of admission, so that you can admission. Okay, and then for importing the data you have to just write df df dot pd. Df is equal to pd dot read csv, and here we provide the link of that data set. So firstly, the first thing you have to do is take that data set in your working directory. So yeah, okay, so it's successfully uploaded this, and you have to just click on three dot and copy path, and then provide the path here, and then run this cell. Okay, so the first step is import libraries. So we have imported the libraries, and the second step is import the data. So we have to import the data, and if you want to just check what is the like how the your data is structured, so you have to just click on this Excel file with the help of, like, chances of admission is there, 0.92 probability of chances of admission. These are the chances of admission. So this is not a classification problem, that's why, because it creates a discrete values, it creates a numerical values. So this is a regression problem. Okay, so that's why I chose this data set. So GRE score is there, TOEFL score is there, university is there, SOP is there, LOR is there. These are all the features in which the chances of admission is dependent, and chances of admission is your target variable. Okay, so if you want to just check your structure of data set in the collab, you have to just write uh, df dot head. Okay, and if I want just 2 lines. Okay, so yeah. Okay, this is the serial number, this is the GRE score, this is a TOEFL score, and this is a university rating, and this is the SOP, LOR, CGPA. What is the CGPA? If a person has a 9.6 CGPA, then high chances of admission, like 0.92 chances of admission. And if a person have a CGPA 8.87, then he or she have a 0.76% of admission. So these are all the features, and we have to predict what are how and what are the chances of admission. Okay, so the next thing, like, if you want to just check your data, so you have to just write df.info. So it gives the total 400 entities are there, 0 to 309, 400 rows are there. Okay, and total 9 columns are there, and these are all in the float type. Okay, and if you want to describe your data set, then you have to just write describe. Okay, and it describes what is the maximum value, what are the counts, like all the values are 400 rows, so 400 counts are there. Okay, what is the mean of the serial number, what is the mean of GRE score, what is the STD, what is the minimum value, what is the 25%, 50%, as you already know about these functions. So the one function is more like df dot. No, first let's define features and target. So how to define features and target? You have to just write, you have to first like, if you write the column name manually, then there is a chance of a spelling mistake. So you have to just write df dot columns. Okay, so here you got the column, and then you have to define very easily, y is equal to df, and the chances of admission, you have to just copy it and paste here, chances of admission. Okay, and this is a key error. Okay, I have catch the mistake. What is the mistake? The variable name is, the attribute name is chance of admit, and the space here, chance of admit, and this is the space here, and we just provide only chance of admit. So give it the space and it works successfully. Okay, and then just define x variable, yeah, df, and mm, what are the features? These are all the features. So you just copy and paste here. Okay, yeah. So here we define x and y, and the next step is step 4, train, test and split. So how to split our data? So you have to just import the module, import the library, which is the library sklearn library. Okay, so you have to just write from sklearn dot model selection is a model selection import train, test and split. Okay, and you have to just write x train, x test, y train, y test, and just apply this function train, test, split. And you have to just provide x variable means features and the target variable means y, and you have to just provide what are the ratio you want. So you want, suppose I want test sizes 70, test size is 30%, so you have to just write 0.3. Okay, and then provide the random state I provide. Suppose any number you write here, so I write here 9598. Okay, and then yeah, and your model, your training and testing data set is splitted successfully. Okay, so if you want to check your check the shape of x and y here, you have to just write f dot shape and y dot shape. Okay, so here you know what is the shape of your 400 rows are there and 7 columns are there. And if you want to check the shape of your x train and y train, so you have to just write x train dot shape and x test dot shape and y train dot shape, y train dot shape and y test dot shape. Okay, so now you have seen here it divided into 70 to 30% ratio, 70 to 30. So 280 is the 70% of 400 and 120 is the 30% of 400. So training data set have 280 rows and testing data set have 120 rows, and here training labels have 280 rows and testing labels have 120 rows. Okay, yeah. And now what is the fifth step? Fifth step is identify the problem. So what we have to predict at y here. So what is the y? So y is a numerical value. Y is a numerical value, like 0.92, 0.76 is a numerical value. So no problem. Like clearly we can say that it is a regression problem. So to just write uh, it is a regression problem. Okay, yeah, so it is a regression problem. So you have to just select the model. For selecting a model you have to just write from sklearn dot, here we import a model selection, but here we import linear model. Okay, yeah, linear model from sklearn is a library, linear model is a module, and import linear regression. I think why it is not giving linear regression. Yeah, So linear regression is an algorithm used for regression problem, and logistic regression is an algorithm used for classification problem. So there are so many algorithms, as I already mentioned in my previous videos, like decision tree is an algorithm, SVM is an algorithm, naive Bayes is an algorithm. So here we use linear regression because it is a very simple algorithm, and it is used for very simple data. So this our data is very simple, so we use linear regression. Okay, you have to just write, yeah, and then just write model is equal to linear, yeah, linear regression, sorry, yeah. Okay, so you have to select, oh, spelling is mistake, so you have to just copy and paste here. Okay, yeah. So we have selected the model, and the next step is fit the model or train the model. So it is the step, it is the step where actually machine learns. Okay, so you have to learn, you have to say that this is only machine learning, not the whole thing. Okay, so you have to just write model dot fit is a function, and you have to just provide x train and y train here. Okay, and run this cell, and your model is learned, your model is trained. Okay, so once you have the trained model, and then the next thing is predict the model. So how to predict the model? So you have to just inbuilt function, you have to just write y predict, model dot predict, and what in which value we want to predict. In testing value we are going to predict now, so you have to just write x test, because for x test, for testing value of features, we provide the features of testing value, and it gives the prediction of we train the value here, and here we provide new data. So testing is a new data for this model, because this model doesn't know what is the testing value. So testing is a it give we give the new data x test here, and it gives the answer which is predicted by our model. Okay, so you have to just write, and if you want to see the result of y prediction, then you have to just write y predict. So yeah, so for the first value it predicts a 0.95, and what is the actual value? Actual value is y test. For x test, y test is the actual value. So for the first entity, the actual value is 0.96, and what is the predicted value? 0.95. Okay, so the for the second value 0.74, and here 0.76, and for a third value 0.83, so here 0.85. Okay, and for the fourth value 0.53 is the actual value, and we predicted 0.63, and for the fifth value 0.92 is the actual value, and we predicted 0.92. Okay, so now you have to differentiate between what is the y predicted and what is the actual value. So yeah, and the next step is the next and last step is calculate the accuracy of the model. Now you are going to now you are able to predict your model on the new data. So how to calculate the accuracy of your model? So you have to just import the libraries like from sklearn. Sklearn matrices is a module, import, yeah. And in classification problem you imported, sorry, LEARN. Okay, yeah, in classification problem you have imported different things, but in the regression problem you imported like mean, absolute error. These are the errors you already read you in that in your theory, in your maths, in the statistics or probability. So you have to just import these error: mean, absolute error. Then you have to just write mean, absolute, percentage error. These are three types of three methods from which we are able to find the error. So you have to just write mean, absolute, and yeah, mean squared error is there. Yes. Okay, so this is a mean square error. Yeah, this is a mean square error. Okay, so we successfully imported these functions: mean absolute error, mean absolute percentage error, and mean squared error. So the next thing we are going to is find the error. So you have to just write mean absolute error for finding. Firstly, we are going to find mean absolute error for finding. uh, how to find error, like y tested, you have to just minus 0.96 minus 0.95, and you got 0.01 0.1. Okay, so this 0.1 is the error, so you have to just provide here y test comma y predicted. Okay, so what is the error here? 0.046 error, so very less error because in it is a in point. So like if you want to like take a variable error, percentage error, you have to just write percentage error. Okay, and here you write mean absolute percentage error, and just provide only y test and y predicted. Okay, and just calculate it. And if you want to see what is the answer of this, so 0.78 is the uh, mean absolute percentage error. So how to find accuracy, because it is a like you have to just 1 minus. If you want to find the accuracy, you have to just write accuracy is 1 minus percentage error. Okay, 1 minus percentage error. So yeah, so let's see what is the answer here. Accuracy 0.92, it means 92% accurate is your model. Okay, so if you multiply it with 100, then it gives the proper accuracy. Yeah, so here we got 92% accuracy, so it's a very good accuracy as we build it in the first time, so it is a very good accuracy. So here we use linear regression model, so that's why its accuracy is 0.9 92%. And here one more thing is mean squared error. If you want to find mean squared error also, then you have to just write as mean. Yeah, okay, you have to just write here okay, and y test and y predicted. So 0.0043 is a mean squared error. So these are all the 8 points, and our model is successfully built. If you provide the new data, then it predicts it. Okay, so yeah, uh, we have built a successfully a model of how to predict the chance of admission. What are the chances of admission? So yeah, our problem is completed. So till now, take care, bye bye, and give your best.